If you like Tesla videos, subscribe to the channel here so you don't miss any news. After 2 years of research and development, Tesla's humanoid robot is nearing human-like capabilities. The sales of its initial versions could revolutionize the tech market, with Elon Musk declaring a goal to produce 1 million Optimus units by 2025. Musk plans to overcome production challenges that have astonished the world. Meanwhile, advancements in AI are driving ambitious developments in Figure AI's humanoid robot, supported by significant investments in what is considered superior technology. How will Elon Musk tackle these challenges, and should Tesla be concerned about competitor technology? Please show your support by subscribing and ringing the bell so you won't miss any of our future videos. Now, let's dive into today's topic. Modeled after the human form, capable of walking on 2 legs, and designed for manual labor, Figure's humanoid robot currently relies on real human input. With millions of job vacancies in the US, Figure's robot is designed to perform tasks that people may not want to do or lack the skills for. It's envisioned to handle more advanced tasks like elder care or cooking. In 2021, Elon Musk shocked the world by announcing plans to build an AI-based humanoid robot. Initial skepticism arose when a dancer dressed as a robot performed on stage. However, when the Tesla bot Bumblebee debuted, it became clear that Musk's promise was genuine. Returning to Figure AI's humanoid robot, their prototype closely resembles the early Tesla bot with a skeletal structure and rigid movements. They have secured $675 million in funding from OpenAI, Microsoft, and Amazon founder Jeff Bezos, valuing the startup at $2 billion. This positions Figure as a notable player in the humanoid robot industry. In the realm of humanoid robot manufacturing, Figure AI is developing a product reminiscent of Tesla's first-generation robot. Interestingly, none of Figure AI's founders have an engineering background. One of the founders, Brett Adcock, previously established Archer Aviation, a company focused on electric vertical takeoff and landing (eVTOL) aircraft to enhance urban mobility. Adcock successfully transformed Archer into a leading electric aviation company, raising over $1 billion in capital, taking it public on the New York Stock Exchange with a valuation of $2.7 billion, and securing a $1.5 billion commercial deal with United Airlines. However, Archer ultimately failed to deliver any products to their partners, casting doubts on the significant investments made by tech giants like OpenAI, Microsoft, and Nvidia in Figure AI, as they appear to be repeating past mistakes. Moreover, it is unclear where Figure AI's platform currently stands in its AI development journey. On the other hand, Tesla, an electric vehicle manufacturer with over 5 million electric cars on the road, leverages AI for real-world operational data collection. Tesla's AI systems are supported by 25,000 NVIDIA GPUs, particularly within the Dojo supercomputer, which has 1.8 exaflops of power dedicated to training autonomous driving systems and AI models. Tesla invested over $500 million to build their supercomputer in Buffalo. Thus, a $675 million investment in Figure AI might not be sufficient to develop their artificial intelligence capabilities. The deal is not yet finalized, meaning their plans could potentially fail. Additionally, the notion of OpenAI as an artificial general intelligence (AGI) is debatable, as it cannot simply be embedded into a robot to enable autonomous navigation and understanding in the real world. In the real world, this presents the most significant and challenging issue in robot manufacturing, which is why Tesla is prepared to take on this risk. Robots must integrate sensory input in a 4D model, understand their environment and their role within it, set goals, decide how to achieve those goals, plan movements, and interact with humans and objects. They then send commands to the motor control system to move the drive system and limbs, ideally with human-like movements to avoid the uncanny valley effect. This sequence of motion planning needs continuous updates as the robot moves, adapting to the changing positions of humans and objects. This complexity explains why we don't see many humanoid robots even in well-funded tech companies. The progress in artificial general intelligence (AGI) and robotics raises the question, how close are we to creating fully functional AGI companions in human-like robots? To address this, we must examine the current state of AGI and robotics, looking at technical, computational, and algorithmic aspects. While there has been considerable development in AGI, it is still limited to narrow AI, which focuses on specific tasks like image recognition or language translation. AGI aims for human-like flexibility, learning, reasoning, and applying knowledge across various domains. Although machine learning, particularly deep learning, has made significant progress, achieving true AGI that can understand, learn, and apply knowledge across diverse fields remains elusive for most companies, including Figure AI. Tesla, with its extensive development roadmap and millions of vehicles collecting data for AI training, appears well positioned to tackle this ambitious goal. The latest revelations from Tesla provide a glimpse into Optimus' movements within the laboratory, showcasing its flexibility before transitioning to a prototype. Optimus exhibits significantly longer strides than FigureBot, with a visible stride distance of over half a foot, while FigureBot's steps lack natural movement. In fact, Optimus can move at a speed of 6 meters per second, marking a remarkable improvement. Tesla announced a 30% speed enhancement for Optimus. Each time the robot's foot touches the ground, impact forces occur. Stiffness increases with the straightness of the knee, causing vibrations that make the robot's movement less natural. Humans avoid this issue with ligaments between bone joints that dampen shocks. Tesla has nearly solved this with 3 major updates. Initially, the Bumblebee version had unnatural steps. In the first update, Tesla improved internally produced drivetrain components, eliminating the need for external suppliers. Tesla claims better balance and whole body control, enabling the robot to easily perform squats. The drivetrain converts input signals into the actual force needed to move anything from the robot's foot to the delicate movements of its fingers. In fact, the finger movements are so smooth that Tesla developers had to confirm that the video showing these movements was not CGI and not sped up, even when Optimus is moving around Tesla's lab. In contrast, Figure AI announced its bot can move at 1.6 meters per second, which is impressive but met with skepticism when observing their provided footage. Tesla's bot features a 2.3 kilowatts battery in its trunk, providing enough power for a full day of work on a single charge, with an optimized compact design. Meanwhile, Figure AI is still in the prototype stage, with a frame and battery that can operate for only about 5 hours. This short battery life could require tethering to a power source, posing a challenge for tasks in factories or human assistance. Optimus also has pressure sensors on its fingers, allowing it to sense and hold delicate items like a thin-shelled chicken egg without breaking it. This practical functionality sets Optimus apart. Additionally, the Tesla bot has a screen on its face to display information, potentially replacing verbal communication. Like a Tesla car, it uses 8 autopilot cameras instead of eyes to understand its surroundings. The Tesla robot's chest houses a full self-driving computer, powering all movements and including Wi-Fi and LTE capabilities. In contrast, Figure AI has not disclosed details on the degree of freedom in their robot's arm joints, making it hard to compare technological advancements. Pricing-wise, Figure AI plans to offer its robot through subscription-based contracts, which could make it more affordable than an outright purchase, though specific costs are unknown. Essentially, the more contracts, the cheaper it becomes, affecting personalization options. To own it in the future, buyers will need to go through a vendor contracted with Figure AI, but the pricing details are still uncertain. Meanwhile, the Tesla bot is expected to be priced under $20,000 once production reaches high efficiency, at least for the initial model. A robot capable of performing any task, including mundane ones, will likely be expensive initially, with potential rental options later. When Tesla starts selling Optimus, prices will likely start high, similar to the Cybertruck or other Tesla vehicles, but will decrease over time. It is anticipated that in less than a decade, robots could be common gifts, with public availability around 2025. Both the Tesla bot and Figure AI bot are considered relatively affordable humanoid robots, but specific cost and availability details are pending. The Tesla bot is expected to be priced under $20,000 and available from 2025 to 2027, while Figure AI bot will be offered through subscription-based contracts with no specific cost or timeline provided. OpenAI's decision to invest in Figure AI reflects a logical step as they have explored ideas related to robots and large language models for some time. Microsoft and OpenAI are negotiating to acquire a financial stake in a humanoid robot manufacturing startup, potentially raising up to $500 million and valuing the startup at around $1.9 billion or higher. The deal is not finalized, and no confirmations have been made. This investment move aligns with OpenAI's interest in combining AI with humanoid robots, although it doesn't mean robots will have ChatGPT in their brains. OpenAI once had a robotics division but now focuses on mastering intelligence and perception first, believing this is a priority before adapting to physical forms. When robots can think independently and hardware improves, they could transform the job market, especially in manual labor fields. Initially, it was predicted that AI would take over manual labor tasks first, but the impact on creative roles is becoming evident, as shown by OpenAI's introduction of Sora, which can replace artists and filmmakers. This scenario parallels Elon Musk's experience with OpenAI. Musk, who co-founded OpenAI with a non-profit mission, left due to disagreements and subsequently sued OpenAI for becoming a for-profit company. Elon Musk alleges that OpenAI's collaboration with Microsoft has transformed the organization into a de facto subsidiary focused on maximizing profits. His lawsuit aims to compel OpenAI to adhere to its founding mission of developing AGI for the benefit of humanity, rather than serving the interests of Sam Altman, Greg Brockman, and Microsoft. Musk has long criticized the potential societal risks posed by AI advancements, advocating for protective measures to prevent AI systems from replacing humans. Investors perceive Tesla as a threat to their technological developments, prompting them to invest in Figure AI or similar humanoid robot technology companies to disrupt Tesla. Each company has its own narrative. For most, designing their own chip is extremely challenging. However, Tesla, one of the largest developers of autonomous vehicle technology, sees it as a worthwhile investment. At the Hot Chips conference, Elon Musk revealed the advanced AI chip design secrets, stating that only 2 chips are intelligent enough to enable full self-driving for the upcoming Tesla model. These custom AI chips have significantly optimized performance, 21 times greater than previous NVIDIA chips, and production costs are 20% lower. Each of Tesla's AI chips runs at 2 GHz and performs 36 trillion operations per second. NVIDIA remains a chip supplier for Tesla, but due to high demand for self-driving vehicle training systems, Tesla decided to build its own supercomputer. The emergence of full self-driving, FSD, in Tesla vehicles could significantly impact the company financially and in production. Widespread deployment of FSD would substantially increase revenue, with long-term financial benefits becoming more pronounced as FSD efficiency boosts production volumes and profitability. Similarly, the implementation and utilization of the Tesla bot across various industries could drive substantial revenue, with each unit serving as an income-generating asset. Scaling up Tesla bot production and integrating automation in Tesla factories would enhance manufacturing capabilities and drive profits. Figure AI appears to be a clear imitation of Tesla's Optimus, making it unlikely to surpass Optimus unless it incorporates Tesla's FSD or has millions of pre-existing training units. Looking forward to new innovations for Optimus in 2024, we hope you enjoyed this video. If you did, please like and join the TeslaBot family by subscribing to our channel, and hit the bell icon to not miss any of our awesome videos. We value your feedback and your time. Thanks for watching, stay safe, and have fun.